Okay, so today we'll be continuing on with this project that we started on last time, a simple dip switch driven LED. We'll be doing the board layout, so we want to start by, on the schematic, you come up here and click on the board tool. Ask you, do you want to create this board? It doesn't exist. Say yes. And it'll go and take all the parts in your schematic and make a board out of it. Not much of a board, doesn't really have anything, but it's a start. It has all your parts. You'll notice this white box up here. That is the maximum size board that you can draw or design or lay out with the free version of Eagle. So we're going to slide all our parts inside that. Give them a little bit of space. Go ahead and put our dip switches in there close to our power. This is the side of the decoder that's going to go to the dip switches, so stick him in there, and we'll just drag all our resistors over for now. A lot of the commands on the board are the same as the commands on the schematic, so if you ever get confused, move can be used F7, and a lot of the other ones are the same shortcuts. So first thing we're going to do is connect or create a ground plane. Do that by using the polygon button. You can come in here and we'll just guess that we'll be able to fit everything in that big of an area. And then you come up here and rename it. Call it GND. Say OK, this entire polygon. And there's a ground plane. So if we hit rat's nest, it'll go in, it'll show you the ground plane, and all your ground connections that are through hole will already be made. The next thing we want to do is go ahead and connect the powers from our BNC up to our IC and our dip switch. We want a nice big fat trace so we don't lose, so we don't drop much voltage across the trace itself, and can actually deliver the voltages we expect to deliver to the board. Go in here and connect the rest of these guys. Come around this back side here. Now, even though these are much larger than the pad, it doesn't really matter. It doesn't know the difference between the pad and the trace when you actually go to route it out and create the board. We'll connect our dip switches up. Take the trace back down to 16 mils or 16 1/1000ths of an inch. Connect these guys up. So it's a lot like drawing the nets, just now you're doing it electrically, and so things can't cross. They have to kind of make sense. It's kind of like putting a puzzle together. So there is our dip switch. It's all hooked up. Our decoder is mostly hooked up. We still need a couple grounds. You can see this air wire right here. It's going to these two grounds. There are two ways you can do this. There's the lazy way. Just go ahead and click on one of these guys and bring it out here to wherever. Click down so that it'll anchor it there. Go to the bottom layer and click anywhere, and you're good to go. When you hit rat's nest, it knows that that's connected to ground. Oh, we missed a power over here. The other way is to go ahead and create your own via, and that's useful when you want to specify a via size. In this case, I don't really care. Just go ahead and rename it, call it ground. Tell it that you want it to have the name ground, and go ahead and connect your pin to your via, and you've got all your grounds connected. So here we are so far. We still need to connect the resistors, but that's it. So this is where it gets a little bit trickier, because there's no easy way like there was over here where we just draw some traces out and it connects all nice. We actually need to think about it. I've gone ahead and done this ahead of time, so I made sure I knew what I was doing, and found this to be the easiest way. So what I'm going to do, I'm going to line some of these resistors up so I can run a trace in between them. So I'm going to come up here, connect this guy, and take advantage of the space between the two pads of this surface mount resistor. So now I've managed to go essentially between these two pads and give myself a little extra breathing room. But I didn't leave myself any space for that other trace to come out for the R7. Move that guy out a little bit. And come back in here, change my width back to 16 mils. Now if I had tried to go between those two pads with a 16 mil width, it would have been too happy. It would have complained because it's kind of hard to route those out when you actually go to manufacture the board. And one important thing to do is make sure you know the design rules of the PCB house you're going to use. You get what you pay for. If you want to pay a pile of money, you can do just about anything you want. If you want to go on the cheap, like most people do that use Eagle, you kind of have to play by their rules and make sure you got all your traces and all your vias the right size. That's how they manage to do it cheap. They limit their investment in drills and tips. So we're going to go ahead and throw these guys down over here. And we'll start tracing these out. It's not quite where I want it. Don't suppose it really matters. And since I deleted that trace, it doesn't think it's actually connected. Now it does. Now we'll do the same thing here with R5. We'll bring this trace down through the middle, again with a 10 mil trace width. And we can start connecting up the rest of our traces. Again, a little bit of creativity goes a long ways. Shouldn't be too difficult to make this board. Why did that connect? There we go. Oh, where'd I go? Drag this guy down. Same thing here. Now we're going to need to create a little bit more space here. We need to bring R1 and R2 between the pins. Consequently, need to bring them between each other too. So let's go ahead and drop these down just to make that more evident. Now one thing, if you're going to do high-speed designs, which this obviously isn't, you need to be careful about 90-degree bends in your traces. They'll get you. They'll cause some signal integrity issues, and you'll start losing your signal really fast. Bring that guy through. Oops, did that with the wrong one. Back up a little bit. Thought I had this guy. So you'll notice it offers radial bends. And again, in high-speed applications, you really want to stay away from the 90-degree bends. But this is not high speed. This is only going to switch as fast as your finger can flip that dip switch back and forth, so it's not a big deal. And we're almost there. So there we have it. We're going to DRC this. Design rule check. Go ahead and hit check. And it doesn't like the drill sizes. So the drill sizes that I've input as being eligible or valid for this design are don't go this small. So, or they just aren't available. So I'd have to go back and clear those up, make sure that the board house I'm going to has that drill size. If not, I need to change it and possibly move those vias out. Otherwise, I need to just bring this board in. Might be a little too far. And we're good. Hit rat's nest, it'll clean up your ground plane, and we're done. So I hope that all makes sense. I hope I didn't go too fast. Again, I have the 10-minute time limit with YouTube, so good luck, and we'll be back with more later.